So physicists, let me have your attention up here, please. Thank you. Just a couple of logistics, and then we're going to jump right in. So I have been kind of living in this daze of, sure, that trimester is coming to an end. And I finally looked this weekend. I was like, oh, like it's literally coming to an end really fast. And I hadn't just like internalized that until this weekend. So I just wanted to share that information with you that the trimester is coming to an end very quickly. Just so that you're kind of aware, if you haven't, been told this before. Today's the 18th. Yeah, you know that. And the first, so 10 school days from now is the end of the trimester. I know, right? It's coming fast. So hold on. Are you going to ask me something about our class with the end of trimester? Or?
I was going to ask about just like the schedule for the end of the trimester, like for the district.
Okay, you go ahead. Ask your question.
So
yes.
Do we have the 4th off then?
The 4th is our records day, yes. Yes, so we go through the 1st. The 1st is our last day of the tri, and then we start 3rd trimester on the 5th. Does that answer your question, Henry?
Yeah.
Okay, awesome. All right, so that's the first thing that I just wanted to let you know, since I was just kind of living in a fog prior and wasn't aware of that. I sent you an email saying that I was updating grades, and I did some of that, but I have a bunch of things that, I've got homework from the last unit that I did not get put in yet because I just haven't gotten it graded, but I will get that done. A number of you, I feel like this class is the one where you take advantage of the turn things in late a lot, much more frequently than even my freshmen, which is interesting. I'm not going to comment on that. I'm just going to make that observation and move on. But anything that you turn in late, I grade on my time. Okay. So if you turn something in late and you want to know what your grade is, then you get to wait until I grade it, because that's how that goes, which is not to say that I'm going to hold it out and tease it ha 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 ha, but I'm also going to get it done when I get it done, as opposed to, right away. So I just want to let you know that. I put in scores for the simple harmonic motion test and the waves test, just so they were in there, being well aware that I have not put in any correction scores. Okay. So if you are going to do corrections on that, they have to be done this week. I'm not going to, that's not going to keep going because we don't have time or whatever for that. Yeah.
What if you come in both the read times and you still don't get them done?
Then you can talk to me individually,
okay.
And then we can figure something out. But besides that, it's not going to be a thing.
Yeah.
Does that make sense? If it's an extenuating circumstance, then we'll deal with that. But anyway, because I want to get all that stuff cleaned up and done so that it's not hanging over your head, so that you know where you're at and all of that. Okay. So then, kind of looking forward, as I was going through our calendar and trying to figure out where we are going, I feel pretty strongly that my primary responsibility with you all is to get you ready for an AP exam, not to get you ready for the end of trimester 2. So that to me means, and I want to run this by you guys because I want to make sure that it's a decision that we're making kind of as a team, as opposed to just that I'm imposing on you, is that we're just going to keep cruising, because it does not really make sense for us to take a test with 2 things left to do in a unit. Are you with me there? So that we can have another test for trimester 3. Okay. So I'm going to keep cruising through this stuff. We are not going to have a test at the end of the trimester, like a final, like we otherwise would, because if we hadn't had 17 snow days or whatever, then maybe we would, but we just don't have time. Okay. So we will have a test at some point once we get all this done. It will certainly be before spring break, well before spring break, but it's not going to be before the end of the tri, unless, I don't know, something weird happens. Okay. And we're just going to keep cruising. I will tell you that I liked the idea, and I like the idea of coming back to all of the other stuff as well, because on that AP test, we're going to have, it's cumulative, right? It's not just what unit you did last. So there will be some sort of finally thing that will appear probably right before spring break. Okay. But I don't want to force it in the middle of something, because I don't feel like that's good for any of us. Okay. So there'll be a finally, that's not the word I want. A finals-like thing right before spring break, or somewhere right in there. Okay. Does that seem okay and fair to you all? Are you sad not to have a test right before the end of the trimester? I don't want to like disappoint. If you guys really want to take another test, I can certainly write you one. But I feel like that's a better use of our educational experience. Okay. So today we're going to do a ranking task. I've got an applied problem for you to work on in as a partner, and then I've got some more equilibrium problems, and this will be kind of our end of equilibrium stuff. And then tomorrow, I wanted to give you one extra day to work through homework because I kind of just threw it all in there this weekend, and so I wanted to give you a chance to like dig into it prior to discussing it. So this is all the homework that you've had up till this point from this unit. We can go through any of it tomorrow at the beginning of class. Yes?
What did you add yesterday?
I didn't add anything yesterday. I added some stuff on Saturday night.
Yeah, whatever that was.
So it's all just here. So I didn't change anything that was already there. I think that like these two things were there before.
Yeah.
So I just added the rest of this. Yeah. But obviously you don't have to do this stuff yet. You're just going to do this stuff. Does that make sense?
Yeah.
Okay. Yeah. So hopefully that's okay. All right. Does that all sound fair? Sweet. All right. So we're going to do a ranking test. So get out some sort of notes or something if you need to write something down. And I'm going to throw the ranking task on the board for you to look at.
It's cozy.
I like you guys a lot. Write down an answer on your board so I can see it. Write down an answer on your board so I can see it. It's a.
Where's your A action?
How'd you know that?
All right. All right. I'm seeing a lot of here. Hold on. BDCA. Not everybody, but some people. It's still frozen. There you go. Talk me through what to do. That rhymed. Good work. Who's got this? You gonna get us started?
Okay, I don't know much about torque.
That's okay. Get us started where you're at.
I don't know much about, I'm sick, sorry. I don't know much about torque.
Okay.
But
But
I know that the bigger the angle, the more important, like the more torque it has, right? Something like that.
sure.
And then
I think. I mean, what? Tell me what you mean by that.
well it's angular, right? Like it's rotational.
True.
And I know that rotation can mean degrees. And then B has a 90 degree,
Okay.
fatter than 60 or 30. So
Okay.
I know, so I assume that'd be big. And then because it's big, it's at the top. And also it's 100 kilograms.
Okay. So this one's big angle and big mass, so it's going to be a big torque.
Yeah, it's going to be fatter torque, baby.
Don't even know how to respond to that, but okay.
Sounds like a Ford commercial.
It does. and then so that was your argument, right? So okay, so I'm gonna actually write that down because I think it's interesting. So for torque, you said the bigger the angle and the bigger the mass, the bigger the torque.
Yeah.
What do you guys think? Does that
In this instance,
seem okay?
In this instance.
Let's talk about it and make sure we're all still on board, though. Connor, what are you thinking?
Well, because for torque, the force has to be perpendicular to whatever it's pulling on.
Okay.
So, as the theta gets smaller, there's less of a perpendicular force acting on the rod.
Okay.
So
like in A, the force goes down like this, but you're saying that the only part of the force that I get to count is the one that's perpendicular? Okay. So it's just like this part here.
yes.
So I want to make sure that we're now moving from the like intuitive thing to the let's figure out how to get to it thing, right? So I want just this part of the force here, which, how would I find that part? Like if I was actually going to do the math here.
What one? The green degree?
I want this little guy here. Yeah. So FG sine 30, because that's 30 also. Does that make sense? So I want just this little part here. So that's going to be FG, the force going down times the sine of 30. So it's just that little piece here. Whereas on this one, on letter C, it's the same FG, isn't it? But now I get to have more of it perpendicular. And so therefore this one's got to be bigger. So C's got to be bigger than A.
Yes.
Yeah. So you're right. The bigger the angle, the bigger the torque, as long as you're measuring the right angle. You with me there? Which is why it always makes me nervous to say, oh, it's just going to be F times R times the sine of theta, because you never know, like, are they telling us this 60 or are they telling us this down here? You know what I'm saying? So I just want you to be careful with that, because you don't want to get tricked into just like saying, oh, it's got to be bigger, so it's bigger, right? Okay? Because this one has a really big angle down here, whereas this one, you know what I mean? Okay, so just being aware of that. What if these all said 50? What if they were all 50 kilograms? How would B and D compare? Same, right? Even if they're different sizes, as long as they're the same force, right? Because torque is equal to, what's the equation for torque? Where they have to be perpendicular one another. Yeah, that's the way I like to write it down. But, you can write in the sine theta or whatever too. How are we feeling? Are we okay? All right, we're going to keep cruising. So the rest of the day today, I've got 3 problems for you to work. One is an applied problem that you're going to work on in pairs in here, and you're going to turn in before you leave today. Okay? I think that should be no problem as long as you stay focused. And then I've got 2 other additional problems that I printed out for you that are just, I think they're fun rotational equilibrium problems. I don't know if you would agree with that adjective or not, but they're interesting. So I'm going to encourage you to work on these if you get done with the other ones. Otherwise, you're going to take them home and they're going to be extra things for you to work on. I will write out solutions for these and post them up so you can see them as well. Okay? So here is the applied problem. Question or stretch? Oh, are they not up? Yes. If I forget, I'm sorry. Yes, I forgot. I told you guys it was going to happen, right? If I forget by the end of today, will somebody email me and just say, hey, post solutions, and then I'll get it done for sure. Thanks for reminding me. Yeah. All right, here's the applied problem. You're going to mass a meter stick. Easy peasy, except I'm not going to give you a scale until the end. Okay? So you're taking a meter stick. You're going to take some weights, and you're going to make a little cantilever. So a cantilever just has some sort of mass out over nothing. Okay? And then you're going to take that, you can put it wherever you want, I don't really care. And then you're going to move this out, and there's going to be a point at which, if you move it further, it's going to tip. Do you see that one's kind of like coming up a little bit? Yeah. Yep, so that's like the exact balance point. If I move it any further, what's going to happen? Right? So we don't want that. We want to find that spot where it's just magically balanced. Okay? And then using that, I want you to find the mass of the meter stick. And you're going, this is why you get to work with other people, right? You get to talk about this. You're going to work in pairs. So you're going to make appropriate measurements to determine the mass of the meter stick. You don't need to make like multiple measurements. Like come up with one setup. That's fine. It doesn't have to be like trial. None of that, okay? I want each person to write up a quick write-up, but it's not like long and big and scary. All you need to have is a clear free body diagram, the net force and net torque equations, and use those to figure out the mass of the meter stick, okay? And then a percent error, because I'll get you a scale so you can measure it, okay? So there are you only need a couple of little slotted weights. They're right behind Ellie on the table over there. You guys know where the meter sticks are. Everything else should be good. Sound good? Go.